this unit covers the word problems that go with solving systems. So the solving systems we just got through talking about. There's three ways to solve the systems. Well, obviously there's a graphing way, there's a substitution way, and there's an addition. Now, for word problems, most of the time you'll use a substitution or an addition method. It's probably not likely that you're going to ever have to do a graphing problem with solving systems of equations by word problems. But the thing that you have to remember is that you are solving a system of equations, and when you're solving your solution to any linear equations, a system is supposed to be an ordered pair. Now, on anything that we've done in 4.1, that should be, your answer should always be an ordered pair. Now, however, when you're working a word problem, you're going to be finding two answers that satisfy the question, and so more often than not, you're just going to label the two answers that are there. So you're going to always be finding two different things. So if you have two things that you have to find, then you have to have two equations to work together. So you'll always have two equations with two unknowns. Now, later on in algebra, you'll do these with three equations and three unknowns, but essentially it's going to be the same process as to what we do this. It's just a little bit extended. So again, what I've told you before when you work word problems, you first have to identify the variables. You have to tell me a let statement so that I know what it is that we're working with and what your variables mean. Then you write your equations and you solve the system, whichever method works better. Now again, it might be substitution, it most likely is going to be addition. Substitution is if it's something that you have figured out how to do and you understand it. Sometimes the problems are worded in a way so that one variable will be by itself and it'll be done by substitution. So you need these three things to get all your credit, and then at the end make sure that you check for math accuracy and reasonability. Make sure that your answers make sense. Again, what we talked about in word problems before applies here. Sometimes when you're finding things, you're not going to get a fraction for an answer. Sometimes you're not going to get a negative number. So be sure that you check for reasonability of your answers. And then at the end, I ask you to write a short sentence about what it is that you found. So you'll see as I go through these problems that these are my expectations for you on a test. Okay, it says the sum of two numbers is 48. Well, sum means that you're going to be adding two numbers together. So then we know that we're going to have to identify two variables here for those numbers. Twice the smaller is subtracted from the larger. So that means we put the larger number in front and the smaller in the back. The result would be 3. Find those two numbers. So we've got to find two numbers. So in this case, numbers can simply be identified with x's and y's, but we have to distinguish between one being smaller and one being larger. It really doesn't matter, but you can say let x equal the smaller number and let y equal the larger number. Now you can't just say equal a number because here we have to distinguish between the two. And so then we start working with our problem. So you're going to have two equations, and the information is going to give you that. Sum of two numbers. So sum means add. So I'm going to add these two unknown numbers together. X plus y equals 48. And then it says twice the smaller is subtracted from the larger. Well, my larger number is going to be y. So I'm going to have y minus 2x equals 3. Now, if we're going to do it by addition, our variables have to line up underneath each other. So in this case, it would be best to go ahead and switch places on these two when you solve it. So I would say x plus y equal 48 and move this to negative 2x plus y equals 3. So now I have my variables lined up. I have a system of equations where they're both in standard form, and all I would need to do is figure out which variable I want to eliminate. If I eliminate x, I could multiply by positive 2, multiply that all the way through. The easiest thing would be to eliminate the y's because they're already got the same number on the front. They just need their signs changed. So if I'm going to eliminate the y's, then I'm just going to multiply the top equation by negative 1. So now my equation on top will be negative x minus y equals negative 48. Then I'm going to keep the bottom equation will be negative 2x plus y equals 3. So here's my equations I'm going to work with. My y's are going to cancel out. So then I have negative 3x is going to equal negative 45. Divide both sides by negative 3. So x is going to equal 15. Now you have to take your x answer and go back and plug it back in. The easiest one to plug it back in would be this one right here. So I'm going to take my x, I'm going to go back up here and I'm going to plug it into this. So really to find y, I just need to subtract 15. So 48, because x plus y is 48. So 15 plus what will equal 48. So just subtract. So that would give me y equals 33. So my two answers would be 15 and 33. Now, when I ask you to write a little statement, just write this. The numbers, and you can even use symbols, the numbers are 15 and 33. And you don't the order that you put them in doesn't matter. So this is what we're looking for. Find the problem, find the answers, and then write me a statement that tells what they are. Okay, the difference between two numbers. All right, so we're going to use this same let x equal. I'm not going to rewrite it. We're going to use that same let statement right here. The difference, so this time we need to subtract those two numbers. So my larger number is going to be y, and if I'm going to subtract them, then I want my larger number in the front here. So I'm going to have y minus x equals 4. Then the larger is 5 more than twice the smaller. So the larger is y, is means equal, 5 more than twice the smaller. So 2x plus 5. Now this problem is set up to do substitution. So I would take where my y is, I'm going to replace it with this value. So I'm going to rewrite the top equation and make it be 2x plus 5, because that's what I'm plugging in for y, minus x equals 4. Now I only have x variables, and so when I get through, I'll get an answer for x, and then I can go back and plug it back in. So I have 2x, and just drop the parentheses, minus x would be x, plus 5 equals 4. I'm going to subtract 5. So I get x equals negative 1. Now I'm going to take this answer and I'm going to go plug it in right here, because if I do, it's going to tell me what y is. So I'm going to have y equals 2 times negative 1 plus 5. So this would be negative 2 plus 5. So y equals positive 3. So then I have two numbers, and again I just say the numbers are both answers, negative 1 and 3. And that's all I'm asking for a statement. It doesn't have to be a dissertation, but a short statement that tells me what you found out. Now, these other problems are working through a different kind of problem. They have sets of things, and so we have to figure out what we're looking for. And if we go to the last sentence, it'll tell us what is the cost of an apple pie and what is the cost of a pecan pie. So my two variables most likely would make sense to be A and P, but what they're representing is the dollars for those. So my let statement says let A equal the dollars for apple, and let P equal the dollars for a pecan pie. Now we're going to set it up to look like just like that. So apple pies and pecan pies are being sold. This should be Casey. I'm not sure why that typo, what that typo is. So Castell, I guess, and then nicknamed Casey. Okay, so they got 6 apples and 4 pecans, and it cost $80. Now this represents cost. So 6 A's plus 4 P's is going to equal $80. Gabriella sold 6A plus 5P, and it's going to equal $94. So if we subtract, if we just multiply through by -1, we'll get our A's to cancel out. So there'd be -1 right there. And that just changes my signs. So now I have 6A plus 4P equals 80, and -6A minus 5P equals -94. Now this would be a problem that you have to be careful with your signs, because your signs might get messed up and then it would come out to be a $, and that can't happen. So here these will cancel. I get -P equals -14, and divide by a negative, so P equals $14, and then it says 6A plus 4P. Okay, so now we have to take P and go back and plug it into one of the equations. So I'll just plug it into the top. So I'm going to say 6A plus 4 times 14 equals 80. So 4 times 14 is 56. So I have 6A plus 56 equals 80. I'm going to subtract 56 on both sides. So grab your calculator. 80 minus 56, 24. So I get 6A equals 24. Divide both sides by 6. So A equals $4. So $4 for apple pies and $14 for pecan. So then make a short statement. Apple costs $4, and you can write it like that. And pecan costs 14, and put a $sign on them. So there's your sentence. Okay. All right. The last one is very similar to that. Two schools are planning a bus trip somewhere. They are taking, let's see, we got high school A and high school B. Senior class at high school A rented and filled 7 vans and 10 buses with 332 students, and high school B rented and filled 4 vans and 15 buses with 459. So each van and each bus carried the same amount of students. Find the number of students in each van and each bus. So we're looking for the number of people that can go in a van. So I'm going to let V equals the number of people in a van, and then B equals the number of people in a bus. How many a bus can hold, how many a van can hold. Now we do the problem the same way we did this one. So for high school A, check, we got 2 different schools. So for high school A will be one equation. We have 7V plus 10B equals 332. High school B had 4 vans plus 15 buses, and that totaled 459. So this time it's a little harder to get our variables to equal the same thing. If we want to eliminate B, we could get both of these to be 30. If we want to eliminate V, we would need to get both of these to be 28 just by multiplying these two together. Here, we could multiply them together, but that would give us a huge number, so we're best just go ahead and saying, well, they'll both go into 30, so I would use that. A lot of times, if there's no special, if you need to find both answers, then you're just gonna, most students will just take the front. So this time I need to get this to be multiplied by 4. Now I have to get the numbers the same, but I get to get the sign, so I've got to multiply by -7 here. Then I get 2 new equations to work with, so I'm going to distribute, and I'll have 28V equals, calculator, 332 times 4 will be 1328. Then I'm going to multiply by -7, so that'll be -28 minus 7 times 15, check your answer, -105b equals -7 times 459, 7 times 459, 3213, and it'll be negative. Alright, so our V's are going to cancel off. We're going to have a -105 and a +40, so 105 minus 40 will give us 65b, and it'll be negative. And over here we're going to do 3213 and subtract 1328, and that'll be 1885, and it'll also be negative, and since both numbers are negative, our answer will come out to be positive. So I'm going to divide by -65. So you can just, since we know the answer is going to be positive, you just type in 1885 and divide it by 65. So the answer comes out to be B equals 29. So there'll be 29 students on a bus. Now take that and plug it back in where it's easier. Be easier to plug it in this top one. Don't go back to the big numbers, go back to the original. So 29 times 10 will be an easy number to figure out. So I'm going to take the 29 and I'm going to plug it into the top equation. So I'll have 7v. 29 times 10 would just be 290 equals 332. So I'm going to subtract 290. So I have 332 minus 290. Comes out to be 42. So V would equal 6. So 6 people in a van and 29 people on a bus. So then you would just write your short sentence. There were 6 in a van and 29 in the bus. Okay? Alright, now all those problems are pretty straightforward, and the next kind of problems that we're going to work on are problems that have value to them. So one of the equations that you're going to have is going to tell you something about the number of items, and the other equation will tell you about the value of the items. Now, tickets, stamps, items with prices, features that distinguish the difference between things. So you're going to see in this first problem, this is one of my very favorite problems that I like to work with my students, because it shows you that value doesn't always have to be money. So here, our value system will be based on some distinguishing characteristic of animals. There are 25 animals in an open pasture. Some are cows, and sitting on top of the cows are cowbirds. There are 86 legs in all. How many of each animal are there? So we know how many animals there are, and we know what kinds they are. There's cows and there's birds. But this distinguishing feature is their legs. So the value of the animals is based on how many legs they have. So I need to pick variables. So I'm going to let C equal the number of cows in the field, and I'll let B equal the number of birds. So my first equation is going to be based on how many animals there are. So my first equation, I'll have C plus B equals 25. The animals, the number of animals that there are. Now the next one will be based on how many legs there are. So how many legs is a cow worth? Well, most normal cows have 4 legs. So there'll be 4C plus how many legs does a bird have? 2. So 2B, but all together there were 86 legs out in the pasture. So now we base our problem on that, If we want to eliminate, and it says how many of each animal, so we need to find an answer for B and C. In a problem like this, I'm going to eliminate B because 2 is a smaller number to multiply by. So I need to multiply the top by -2 because I need my signs to change. So when I multiply through by a negative, I'll get -2C minus 2B equals -50. Then I'll have 4C plus 2B equals 86. So I'm going to subtract, those cancel off. So again, I'll get 2C equals 86 minus 50 would be 36. Divide both sides by 2. So C is going to equal to 18. So I have 18 cows out there. And if they have to add up to 25, 25 minus 18 will tell me how many birds are out there. So birds would equal to 25 minus 18, which would be 7. So then we write a little statement. There are 18 cows and 7 birds. Now, put a star on that one. That's my favorite kind of problem, so you'll find one like that on your test. Okay, it might not be cows and birds. It might be something else. So I think one year I had squirrels and ducks from the college, and I had students that didn't know how many legs a squirrel had, so I had to kind of make sure that we understand what we're doing. All right, number 6 is the same kind of problem. It has to do with points on a test, and the distinguishing feature would be how much they're worth. So you have 2-point questions and 4-point questions. So they're variables. It says how many of each type. So we need to find how many 2-pointers and how many 4-pointers. Here we might want to use T for the 2's and 4 and F. So I'm going to say let T equal the 2-point questions, and I put just a Q right there, and F equal 4-point questions. Okay, that's enough information to tell me that you know what you're thinking about and show me what you mean. Alright, so the teacher says there's 40 questions on the test. So this is the number of questions on each kind. So the number of questions, T plus F, has to add up to 40 questions on the test. Now the rest of it comes into how much they're worth. So this kind of question is worth 2 points, so 2T. This kind of question is worth 4 points, so 4F, and the total points on the test would be 100. So this problem is exactly like this one. You just need to eliminate one of the variables. Again, I would use the smallest number possible. So I'm going to take this one and multiply here by -2. Then I've got -2T minus 2F equals -80. Underneath I have 2T plus 4F equals 100. So my T's are going to cancel out. I get 2F equals 20. Divide by 2, so F is going to equal 10. So there's 10 4-point questions, and if there's 40 questions in all, that would leave 40 minus 10 to equal the 2-point questions. So 30 would equal your T value there. Then you would write there are 10 4-point and 30 2-point. Okay, number 7 has to do with coins, and money has value. So we're talking about quarters and nickels here. We have 35 coins, so one of our equations will be the number of coins. So we're asked to find how many coins. So the question says we need 2 variables to represent quarters and nickels. So again, This time we'll use Q equal the number of quarters, and you can abbreviate, and N equal the number of nickels. Now, the one thing about this is that this value is given to you in dollars, $3.75. When we think of quarters, we think of them as 25 cents or 0.25 if we're talking in terms of dollars. So the easiest thing to do here is to simply make this be 375 cents, and so move that decimal out of the way, and then when we work with the money, we can have 25Q, so for each quarter it's 25 cents, plus 5N, so the total amount of money would be 375 cents. The coins, based on number value, would be Q's plus N's have to total 35. So this is just telling me how many coins I have. The second equation is their monetary value. So this problem would set up and work just like these. It doesn't change. You would eliminate, I would eliminate, since it asked for both, I would eliminate the n's because 5 is a smaller number to multiply by than 25. So we're going to multiply here by -5. Then we get -5Q minus 5N, and in calculator, 35 times 5 would be 175. So -175. Then underneath I have 25Q plus 5N equals 375. So here my 5N's subtract. I get 20Q equals 200. Divide by 20. So that would be 10. So Q equals 10. And again, go back up to here. If it has to add up to 35 coins and 10 of them are quarters, then just subtract. So that would mean 35. So N is going to equal to 35 minus 10. So then we have how many nickels? 25. So N equals 25. Now I'm running out of space here, so I'm not going to write the sentence in here, but you would then write there are 25 nickels and 10 quarters. Alright, this problem is exactly the same. It's talking about car wash, how much it costs to wash a car. So it's like tickets. I mean, it's a value, it's a price of something. So one of the equations will have to do with the number of vehicles that are being washed, and the other one will have to do with money, involve money. It has to be two separate ones. So what kind of vehicles do we have? Cars and pickup trucks. So let's use P for pickup. So let's C equal the numbers of cars that were washed, and P equal the number of trucks washed. Alright, so how many vehicles altogether? So altogether I had C plus P equals 57. For money, $5 for each car, so that would be 5C, plus $8 for each pickup truck, and the total amount of money they earned was $330. So again, same kind of problem, chickens and pigs, cars and trucks, 2-pointers and 4-pointers. Same thing works with basketball. There's just so many different ways these problems can be done. Alright. Now, it says how many of each. In the case that they only asked for one of these variables. So if they only asked for an answer of C, then don't eliminate C, eliminate P. So the easiest one is to use the smaller number. So multiply by -5, and I get -5C minus 5P equals 57 times 5. 285. Then I have 5C plus 8P equals 330. Okay, the C's are going to cancel out. 8 minus 5 would be 3P And 330 minus 285, 45. Divide by 3, so P equals 15. If they have to add up to 57, 57 minus 15 would be 42. So C has to equal 42. So there were 15, there is 15 trucks, 15 trucks and 42 cars. Okay, those are the easiest kind of problems. The hardest ones and the ones that students just cannot stand to do are these last ones. These are called motion problems. Now, motions have a formula. Distance equals rate times time. So if you're in your car and you're going at an average speed of 70 miles an hour and you drive for 2 hours, you would expect to go 70 times 2, which would be 140 miles. So the rate that you're going times the time that you go equals to the distance that you go. Rate times time equals distance. So we're going to use this formula to do, it's going to be our equation formula. The information is, I always have my students set up their information in a box. So that's why the little boxes are here. You won't have to do a let statement because you'll be using your box. So here we go. John and Cindy row their canoe 26 miles downstream in 2 hours. So 26 is your distance, 2 hours is your time. After a picnic, they row back upstream. After 3 hours, they've only traveled 9 miles. So now their distance is 9 and their hours is 3. But the problem is, assuming that the canoe is a constant rate, the river's current is involved in their speed. Okay? The boat is moving and the water is also moving. So when they're going downstream, that means the water is helping them. When they're going upstream, the water is pushing against them, so they're not going as fast. They're losing speed. So when we set the problem up, on the box side, you want to put down and up. Downstream and upstream, okay? Down and up. Two different directions that they're going. Now, the downstream went 2 hours, so we're going to put a 2 right there, and it went 26 miles. The upstream went 3 hours, but they only went 9 miles. Now, how fast were they going? Well, the speed was involving two things. It was involving the speed of the boat, which we'll call R, the rate that it was going, plus the speed of the current. So it's R plus C because the current is helping to push the boat when it's going downstream. Now, the opposite happens when it's going upstream. It's losing some speed, so this time losing would be subtracting the distance, the speed of the current. So the current is causing them to slow down. Now we go back and we use our formula. We're going to take our rate, R plus C, times the time, which will be 2 hours, equals 26. Then we're going to take the upstream, R minus C, times 3 hours equals 9. Now here's the trick to this problem. Instead of multiplying through with the 2, what you're going to do is we're going to divide it on both sides, and it makes the problem get smaller instead of getting bigger. Okay, don't distribute your 2 right there. We're going to divide it off. So our new problems are R plus C equals 13, 26 divided by 2, and divide off there, and you get R minus C equals 3. Now we have a super easy set of equations to work. The C's are already opposite, so they're going to cancel off, and I get 2R equals 13 plus 3 would be 16. So R is going to equal 8. So that would be 8 miles per hour, right? We're just going miles per hour. And over here, the current. Okay, so go back up to the top. The rate plus the current has to total 13. So if the rate is 8, then the current has to be 5. Okay, then you would just tell me, there's my sentence, the boat goes 8 miles per hour and the current is 5 miles per hour. Okay, a short sentence. So there's your answer, and you have to label your answer. Now, if the problem starts coming out with negatives here, that means you put your C in the wrong place. Downstream always has the current helping it. Upstream, you're always pushing against it. Now, when you work with wind speed, we don't call it upstream, downstream. Wind speed has a different designation. Okay, with wind speed, we call the current headwinds and tailwinds. Now, headwind is pushing against you. Tailwind is pushing at your back and helping you go faster. The problem sets up exactly the same way. So when the wind is helping you, it's a headwind, okay? You've got the wind going with you and helping you. So let's go with and against, and you can just put AG, against, with the wind and against the wind. I always put the with statement or the downstream statement in the top box. Okay, so let's look and see. The plane flew from its home base at an airport 255 miles away with the headwind, so with the help of the wind, it took 1.7 hours. So I'm going to put 1.7, and it went 255 miles. The return trip is the same distance. It's still 255 miles, but this time it took them, oh, these are wrong. That's wrong. I'm sorry. This should be 1.5, and this should be 1.7. Okay. Against the wind should always take longer. Okay. Against the wind should always be longer than with the wind, because you can go faster with something pushing you. Alright, so here we have R plus C, and here we have R minus C. It sets up the same way. So the headwind is against you. It's going to take you longer than when you got a tailwind pushing you. Now we do the problem exactly the same. So we have R plus C times 1.5 equals 255. And we have R minus C times 1.7 equals 255. Okay, again, divide off the 1.5 and divide off the 1.7. Then the problems will get a whole lot quicker and a whole lot easier. So we'd have R plus C equals 255 divided by 1.5 comes out to be 170. And then we have R minus C, and 255 divided by 1.7 equals 150. So we combine the lines together, the C's are going to cancel, and I get 2R equals 320. I'm going to add those together. Divide by 2. So R equals 160. Now, 160, and we go back up here and we plug it back in. Now, 160 is speed, so this is miles per hour. That's the airplane, that's how fast the plane is going. And how fast is the wind blowing? Okay, the current this time is wind, so 160 subtract from 170 would be 10 miles per hour. So that would be a very light wind that's blowing right there. So then you can say the plane flies at 160 miles per hour and the wind is 10 miles per hour. So these problems are all very much pattern based. So if you know these 3 different kinds of problems that we've just been working here, then, or 4 different kinds, you'll be able to do well. But we've got to learn how to solve systems of equations. So good luck.